Good morning, all of you. Welcome to Jee in the Rank Zone. We have done already in metallurgy the extraction methods. Now, in this lecture, we are going to discuss extraction of copper, zinc, and aluminium. So, let us start now. So, this is lecture number 3. First, extraction of copper. So far, we have done how to do concentration of ore and how to get metal from the oxide ore, that is concentrated ore, conversion of ore into metal oxide. Then we have to do extraction of metal. So after that, we have started now extraction of copper. Now in this extraction of copper, we are going to discuss how copper is extracted. Generally, copper is available in the form of, I'm just writing here, copper is available in the form of sulfide ores and oxide ores. So copper ores, you have mainly sulfide ores and oxide ores. So coming to sulfide ore, we have copper pyrites. First one, we have copper pyrites, the CuFeS2 formula. And second, we have bornite, Cu3FeS3. And third, we have copper glans. Copper glans, nothing but cupous sulfide. And in terms of oxide, we have only one word, that is cupite ore, that is red in color. And the formula of this ore is Cu2O, that is cupous oxide. So these are the main ores of copper from which we'll extract. These are the main ores of copper from which we'll extract copper. And mainly in this, we'll extract copper mainly from copper pyrites and copper plants in case of sulfide ores. In case of oxide ore, it is only one ore we have, that is cupite ore. So let us discuss now how to extract copper from these ores. So please listen carefully. From this extraction also they will ask questions. So that's why it is very important discussion. So mainly copper is extracted from copper pyrites and cupite ore and copper plants. This is not available easily. Second one. So let us see now. So copper pyrites is purified by first we have, what is that? Concentration of ore. So copper pyrites is concentrated, best concentrated by, since it contains sulfur, it is purified by fourth flotation process. Fourth flotation process. What is this fourth flotation process? So this already we know, the powdered ore. So in this, what we will take in fourth flotation, powdered ore of copper pyrites plus pine oil plus water, pine oil plus water and air. These all the things we'll be doing in fourth flotation process. This already we know. So powdered ore of copper pyrites is taken along with pine oil, water and air. So this changes into fourth because it is based on the property of wettability of ore. So pine oil has a tendency to wet only the ore particles, not the gangue particles. Since pine oil has the tendency to wet only the ore particles, and by means of air and water, it changes to form fourth. So this is nothing but fourth flotation process. This we already discussed. And to stabilize the ore, we'll add fourth stabilizers. Next, second case, what we have to do? Second point in this is If suppose copper contains non-sulfide ores, it is concentrated by leaching. If suppose copper is having non-sulfide ores, copper is being extracted from non-sulfide ores, it is done by leaching. So that point here is, as we are going to discuss copper extraction from copper pyrites. So that's what we are discussing now. So first step, concentration of sulfide or copper pyrites ore is done by fourth flotation process. In this, what will take the powdered ore of copper pyrites plus pine oil plus water plus air. So it forms fourth. Next, second process in this roasting, that is ore, the copper pyrites ore, the concentrated ore is roasted in the blast furnace with limestone. So copper pyrites on oxidation, that is copper sulfide plus iron sulfide plus sulfur dioxide gas. This the mixture of copper sulfide and iron sulfide is called MATI. This is very, very important in the examination. They'll ask the mixture of copper sulfate and iron sulfate is called MATI. So free sulfur is oxidized and removed as sulfur dioxide. Now in this process, very, very important, please note down, in this process, in this roasting process, what happens, and just note it down. In this process, the arsenic and antimony present in the ore, the arsenic and antimony impurities present in the ore are removed as volatile oxides, are removed as volatile oxides, are removed as volatile oxides. So that is arsenic oxide and antimony oxide. So second process is what? Ore is, that is copper pyrite ore is roasted in the blast furnace with limestone. So limestone is nothing but calcium carbonate. This limestone forms slag. So that is nothing but here. The pyrite is converted to cuprous sulfide and ferrous sulfide with evolution. So this copper pyrite is converted into cuprous sulfide and ferrous sulfide along with sulfur dioxide gas, which is removed. So this, the combination of cuprous sulfide and ferrous sulfide is called MATI. This is called what? MATI. So this is the second process we'll do. So first step, what we'll do, copper pyrites is been taken, the powdered ore is taken and mixed with pine oil along with water and air, it forms froth, and this froth is collected and then crystallized, and this ore is roasted in the blast furnace with limestone. You know what is the roasting process? Heating the ore strongly in the presence of air is called roasting process. So copper pyrites is being roasted at 59 degrees C at high temperature. Then it results in the formation of MATI, and in this process the impurities present along with the copper pyrites are arsenic and antimony, and they are removed by the means of their volatile oxides. Volatile oxides means they will get evaporated. As they are volatile, they will get evaporated. So these are the two steps involved in the extraction of copper. Next, listen. Next, we'll move to third step. So what is the third step we are going to do? So next, third one is nothing but basimerization. This is also called as basimerization. Third step, also called as basimerization. Again, I read the flow chart for the entire copper, so don't worry about it. So this is called basimerization. So what is basimerization? Before going to basimerization, we have smelting also. Smelting of copper ore. Smelting means nothing but in the roasting process only we'll do smelting also. So what is Bessemer converter? Copper sulfide, cuprous sulfide containing ferrous sulfide, silicon dioxide as the impurities are heated with oxygen gas. So ferrous sulfide on reaction with oxygen gas, it forms ferrous oxide along with sulfur dioxide. This ferrous oxide combines with silicon dioxide and forms slag. That is called gangue plus flux. So here this is called gangue and this is called flux. And this is called acidic flux and basic flux we already know. So gangue plus flux gives rise to slag. And the cuprous sulfide combines with oxygen and form cuprous oxide and sulfur dioxide. So Bessemer converter, in the Bessemer converter, we are going to convert cuprous sulfide to cuprous oxide along with sulfur dioxide. This cuprous sulfide So this is called basimization and Bessemer converter. So what is Bessemer converter? The matter obtained from smelting is transferred to a Bessemer converter. Some sand is added. So what is added to Bessemer converter? Converting silicon is added as the impurities is heated with oxygen gas. So is added in a blast furnace of air is blast of air is blown to the molten mass. Then what happens? Iron oxide, that is ferrous oxide, is converted into silicon, sorry, ferrous silicate. Ferrous silicate, it is also called as slag. This is nothing but gangue plus impurities is nothing but slag, and this cupous sulfate changes to cupous oxide. So that's the third step. Formation of cupous oxide takes place. Let us see now fourth step. So cupous oxide combines with cupous sulfide again. This is called very, very important. Undergoes self-reduction. Undergoes what? Self-reduction to form copper, which is commonly called as blister copper. What is blister copper? 98% copper and 2% impurities. 98% copper plus 2% impurities is called blister copper. 98% copper and 2% impurities are called as blister copper. What is blister copper? What is matte? They'll ask in the examination. What is matte? Matte is nothing but the combination of cupous sulfate plus iron sulfate is called matte. So this is called matte, and the matte is being converted into cupous oxide in the basimization, that is Bessemer converter. So the cupous sulfide combines with cupous oxide, undergoes self reduction. This is also called as auto reduction. Self reduction is also called as auto reduction. So auto reduction process takes place, which it changes to copper and sulfur dioxide. So here this is called auto reduction, and whatever the copper is formed, it is called as, it is containing 98% copper and 2% impurities, and this is also called as blister copper. So in the graph, the cupous oxide line is almost at the top, so it is easily reduced. Even at low temperatures, carbon reduces cupous oxide to copper. So as it is in the Ellingham diagram, the cupous oxide is line is at the top. So easily carbon can reduce at low temperatures only. At low temperatures only, carbon can easily reduce cupous oxide to copper. So this is called the extraction of copper. This is called what? Extraction of copper. Let us see now. So this is called extraction of copper. This is the Ellingham diagram. See, copper changes to cupous oxide at the top of the graph. So carbon and carbon monoxide can easily reduce. Carbon and carbon monoxide can easily reduce cupous oxide to copper, even at low temperatures also. Cupous oxide to copper, even at low temperatures also. So this is called extraction of copper. Next, before going to extraction of zinc, I'll give you the flow chart of copper. So please note down. Easily you can understand by the means of this flow chart. So let us see. If you don't remember all the processes, simply you can write this flow chart. For every metal, if you write this flow chart, it is very easy for you to remember in the examinations, entrance examinations questions. So let us see flow chart of copper. I'll try to finish it in one page. If not, I'll take it in next page also. So anyway, we'll do this flowchart at the last better, so that easily we can understand. I'll write flowchart for copper, zinc, and aluminum. So next we have zinc, extraction of zinc from zinc blend, extraction of zinc from zinc oxide and zinc blend. First, generally, zinc blend or calamine are converted into zinc oxide by roasting or calcination. So zinc blend, first what we'll do in the extraction of zinc, first step is common. How do you concentrate? How will you concentrate? Concentration of zinc sulfide can be done by concentration of zinc sulfide can be done by fourth flotation process. As usual, fourth flotation process. And second step, the zinc sulfide. So for concentrated zinc sulfide or calamine are converted into zinc oxide by roasting or calcination. In this case, the reduction of zinc oxide is done using coke. So we'll do only roasting. And the third step, what we have, reduction of zinc oxide is nothing but, so zinc sulfide is changed to zinc oxide. Zinc sulfide is changed to, on roasting, it forms zinc sulfide, zinc oxide plus sulfur dioxide gas. So it is very, very important. You can write the balancing equation. So zinc sulfide plus oxygen, 2 moles of zinc sulfide, 3 moles of oxygen changes to form 2 moles of zinc oxide plus 2 moles of sulfur dioxide. 2 moles of sulfur dioxide, and the zinc sulfide combines with oxygen and forms zinc sulfate, and zinc sulfate changes to zinc oxide, zinc sulfide, and oxygen. So this is the reaction taking place in roasting process. It is nothing but roasting in reverberatory furnace. So zinc is being roasted in reverberatory furnace. Reverberatory furnace will roast zinc. Reverberatory furnace will roast zinc. So first step, concentration of zinc sulfide using fourth flotation. Second step, zinc is being roasted. Zinc or zinc sulfide is being roasted and changes to zinc oxide. And third step, this is the third step we have. Third step, what happens? By the means of reducing agent like coke, zinc oxide is reduced to zinc spelt, and this is also called as zinc spelter along with common carbon monoxide. The metal is distilled off and collected by rapid chilling. So in this way, zinc is being extracted. So this is the formation of zinc. Zinc can be done like this. So only zinc is obtained here. Just only three steps we have. What are the three steps? Concentration of zinc sulfide. Second step we have roasting of zinc. Third step we have reduction of zinc. And fourth step we have purification of zinc by distillation. Purification of zinc by distillation, that is rapid chilling. And zinc spelter contains zinc plus carbon monoxide. This is called Billion process. It is heating done by producer gas. Zinc spelter impurities. What are the impurities? Common impurities present along with zinc spelter. So the impurities along with zinc spelter present are, this is also they ask in the examination. So the impurities are in this zinc spelter. What is the spelter? Spelter, the impurities are lead, comma, iron, comma, cadmium, arsenic, etc. Cadmium, arsenic, etc. These are the impurities, common impurities present along with the zinc spelter, and these are being purified by distillation. What is distillation process? Based on the boiling points, one impurity will be removed off. So first lead will go at only zinc boiling point is 907 degrees and cadmium boiling point is 767 degrees distill lower. From this simple sample, cadmium is removed at 800 degrees. So this is called distillation. Distillation. So these impurities are removed by the means of distillation. The impurities are removed by the means of distillation. So once again, I'll recap the extraction of zinc. It is only a simple process. First, the zinc sulfide ore is taken and it is concentrated, best concentrated by the means of fourth flotation process. Since we have already discussed what is fourth flotation process, that's why I'm not discussing here. So zinc sulfide is taken and is being concentrated by the means of fourth flotation process. Second one, second step, step two, this is step two. So in step two, what happens? The zinc sulfide ore, the concentrated zinc sulfide ore is taken in a reverberatory furnace and then undergoes roasting. So the reduction of zinc oxide. So that is in this roasting, what happens? Zinc sulfide on oxidation forms zinc oxide and sulfur dioxide. So the zinc oxide so formed is being reduced by the means of reducing agents such as carbon. Zinc oxide is reduced by carbon at a temperature of 1673 kelvins and forms zinc spelter. What are the impurities present along with the zinc spelter? The impurities are lead, iron, cadmium, arsenic, etc. So these impurities are removed by the means of distillation. So the metal is distilled off and collected by rapid chilling. So this is in this way we can extract zinc from zinc blend. So zinc from zinc blend, total 4 steps. Step 1, concentration of zinc sulfide. Step 2, roasting of zinc sulfide. Step 3, reduction of zinc oxide to zinc. And step 4, distillation. Step 4 is what? Step 4 is distillation. Distillation is nothing but step 4. So these are the 4 steps involved in the extraction of zinc. So please note it down. Anyway, at the end of this slides, we'll give the flow chart for each and every metal so that it will be easy for you to understand. So next, in this way, we'll extract zinc. Next, electrochemical principles of metallurgy. So the reaction becomes spontaneous if delta G is negative. So the standard free energy change, if it is negative, then the reaction is spontaneous. And delta G is equal to standard free energy change is equal to minus NF E degree of cell. That is electrode potential of the cell. What is E degree? It is nothing but electrode potential. Electrode potential of the cell. Electrode potential of the cell. So it is called as E degree of the cell. So delta G is negative if electrode potential is positive. Electrode potential becomes positive if electrode reduction potential of cathode is greater than reduction potential of anode. Then only it can be positive. The reaction Cu plus 2 plus Fe gives us CuS plus Fe plus 2 is spontaneous because iron can displace copper from its salt solution. So in the cell Fe+2, this is anode and this is cathode. So EDG is positive. So this we have done by the base of electrochemical principles of metallurgy. Anyway, we have discussed this total concept in electrochemistry. So next, in Downs process, what is Downs process? In the extraction of sodium. In Downs process, sodium chloride, sodium ion plus chlorine and forms sodium plus half chlorine is non-spontaneous since E degree of the cell is minus 4.0 volts. So it is made spontaneous by adding EMF greater than minus 4.0 using battery. So in Downs process, we can extract sodium. So that can be made spontaneous. Because of this EDK electrode potential values also, we can giving by applying EMF, we can change the reaction, non-spontaneous reaction to spontaneous. This is very, very important. So it is made spontaneous by adding EMF that is greater, electromotive force greater than minus 4.0 volts using battery. In Nelson cells reaction, the reaction Cl minus plus 2H2O, 2OH minus H2 and Cl2 gas is non-spontaneous at E degree of cell minus 2.2 volts and delta G is equal to plus 4 kilojoules. To make this reaction to take place, EMF greater than 2.2 volts is added from outside using the battery so that we can extract sodium or chlorine or hydrogen gas from Nelson cell. So to make the reaction spontaneous, we can add EMF. That is nothing but by applying current. By applying current, we can make so many reactions into spontaneous. That is make it happen. So that is called electrochemical principles of metallurgy. So this is called electrochemical principles of metallurgy. So please listen. This is very, very important. So if they in the examination for advanced level, they will ask questions like this. In the Downs process, sodium is changed to sodium ions and chlorine are changed to sodium and chlorine molecule is non-spontaneous E degree. How can we make this reaction spontaneous? So if the reaction is non-spontaneous with the electrode potential value minus 4.0 volts, then this reaction can be made spontaneous by applying an EMF greater than minus 4.0 using battery. Similarly, the same thing, if you apply greater than 2.2 volts is added from outside using battery, so automatically the reaction may occur. So by this, what you can understand, if you apply EMF greater than the electrode potential of the cell, if you apply the EMF that is a current by using outside battery greater than the electrode potential of the cell, automatically the reaction becomes spontaneous. Automatically the reaction becomes spontaneous. So this is very, very important case. So I hope you understood this. Next, in the oxidation reduction reaction, sodium gold cyanide oxidized form reducing agent is zinc, and this is nothing but leaching process. This is nothing but what leaching process we already know. So sodium gold cyanide combined with zinc and it forms gold is displaced and it forms zinc cyanide, zinc cyanide. So this is oxidized form, this is reducing agent. Is spontaneous and E degree is positive. So all the spontaneous reactions, by this what you can say, for all spontaneous reactions, for all spontaneous reactions, for all spontaneous reactions, EDG, that is electrode potential of the cell, EDG of cell is should be positive, condition number one. And delta G, if EDG of cell is positive, then delta G is always, since minus NF EDG of cell, it becomes negative. So delta G is negative and EDG of cell should be positive. So this is nothing but the electrochemical principles of metallurgy, electrochemical principles of metallurgy. Next continuation, extraction of aluminum. So far we have done copper, then zinc. Now we are going to do extraction of aluminum. This is also very, very important. Extraction of aluminum from bauxite. Usually extraction of aluminum is done by from bauxite. So in the metallurgy of aluminum, purified aluminum oxide is mixed with, this is directly we have given, first we have done. So let us see now. First step and second step I'll write. Step one, concentration of aluminum oxide. Concentration of aluminum oxide. So in the extraction of aluminum, first usually aluminum is extracted from bauxite. So first step, concentration of aluminum oxide, that is bauxite, concentration of bauxite ore. How it is concentrated by using, first we have step 1, Bayes process. This we already discussed in the previous lecture, that's why we are not given here, but still for your understanding I'm just repeating it again. Second, we have Hall's process. Hall's process. So, and third we have Surpex process. So all these three processes are inverted. So the concentration of aluminum oxide can be done by using Bayes process, Hall's process, and Surpex process. Second method, what we'll do after that, concentration of aluminum, we'll do calcination of aluminum hydroxide. Calcination of aluminum hydroxide. And third step, we'll do electrolytic reduction of pure alumina. Electrolytic reduction of pure alumina. So these are the three steps involved, and then fourth step we have refining. So next fourth step we have refining of aluminium by Hoopes process. Refining of aluminium by Hoopes process. It's Hoopes process. So these are the four steps involved in the concentration in the extraction of aluminium from bauxite. So first, the concentration of aluminium, that is first step, is nothing but concentration of aluminium, that is aluminum oxide, that is bauxite ore. So it can be done either of any of these processes, A or B or C, depending on the type of impurity. First, we have Bayes process. So this process is mainly applied to bauxite ore containing ferric oxide as chief impurity. So if bauxite is containing ferric oxide as impurity, we'll use Bayes process. We'll use what? Bayes process. In this process, what happens? The color of such, usually this ore is red in color and hence called red bauxite. It is also called as red bauxite. Also called as what? Red bauxite. Red bauxite. So this is nothing but Bayes process. So concentration of aluminum oxide can be done either by Bayes process. Bayes process is nothing but if aluminum oxide contains ferric oxide as impurity, it is being concentrated by Bayes process, and in this color will be changed. So it is also called as red bauxite. So what happens for this? The color of such ore is usually red and hence called red bauxite. And how to concentrate aluminum oxide from Bayes process, that we are going to discuss now. So in this process, what happens? For aluminum oxide, we'll add sodium hydroxide. We'll add what? Sodium hydroxide. Then this forms sodium metaluminate and water. Sodium metaluminate and water. So I'll write the equation now. So first process, what is this? Bayes process I'm writing here. Please note it down. Bayes process. In this, what happens? Hydrated aluminum oxide, that is called red bauxite. Red bauxite is treated with sodium hydroxide. This is called what? Red bauxite. Because what is containing in this? Ferric oxide as impurity. Ferric oxide, if bauxite contains ferric oxide as impurity, we'll use as impurity, we'll use this method, that is Bayes process concentration. So for this, what happens? Sodium hydroxide is added. Sodium hydroxide is added, which forms sodium meta-aluminate. Sodium meta-aluminate along with water. This sodium meta-aluminate is soluble, and this sodium meta-aluminate combines with water. Sodium meta-aluminate combines with water and forms sodium hydroxide along with aluminum hydroxide precipitate. So this is nothing but concentration of bauxite, red bauxite. So always aluminum hydroxide is formed as a final product, and this aluminum hydroxide, when heated strongly, this aluminum hydroxide On heated strongly, it forms aluminum oxide. Aluminum hydroxide on heating strongly forms, that is around 1500 degrees C, Strong's aluminum oxide forms aluminum oxide. So this is the steps involved in Bayer's process. So ferric oxide as impurity, then we'll concentrate the aluminum oxide bauxite ore by Bayer's process. In this process, aluminum oxide, that is red bauxite, is treated with sodium hydroxide, which forms sodium metaaluminate. Sodium metaaluminate, soluble sodium metaaluminate. Sodium metaaluminate. This sodium metaaluminate on dissolving in water forms sodium hydroxide and aluminum hydroxide precipitate. Aluminum hydroxide precipitate. So this aluminum hydroxide insoluble material is heated strongly at 1500 degrees C. That is nothing but this is process is called as calcination. This process is called what? Calcination. And finally it forms aluminum oxide. This is called concentrated ore. This is called what? Concentrated ore. Next. So the aluminum oxide can become bauxite can be concentrated in three processes, that is Bayer's process, Hall's process, and Salpex process. Now let us see Hall's process. Second one we have Hall's process. These are all not given in the PPT, that's why I'm writing here. So please note it down. This is additional information. So if bauxite is fused with sodium carbonate, so what happens if bauxite contains ferric oxide, it can be done even with Hall's process also. So here what happens? The bauxite combines with sodium carbonate. Bauxite combines with what? Sodium carbonate. It is fused with sodium carbonate. So what happens? It forms sodium metaaluminate. Sodium metaaluminate along with oxygen, carbon dioxide, sorry. So this sodium metaaluminate combines with carbon dioxide and water. It forms aluminum hydroxide precipitate along with sodium carbonate. Sodium carbonate. So this aluminum hydroxide on strong heating forms at 1500 degrees C. This is called calcination process. It is called, it is formed aluminum oxide along with water. So if aluminum oxide contains ferric oxide as an impurity, it can be concentrated by either Bayer's process or Hall's process. In Hall's process also, the fusion mass is extracted with water where ferric oxide and silicon dioxide remains as precipitate. So in this, ferric oxide and silicon dioxide remains as precipitates that can be easily filtered off. So what are the impurities present along with this? Ferric oxide and silicon dioxide. Ferric oxide and silicon dioxide. Suppose if both ferric oxide and silicon dioxide is present, we will use Hall's process. If only ferric oxide is present, we will use Pierre's process. If only silicon dioxide is present, we will use the aluminum oxide is best concentrated by Salpex process. So let us discuss now. So next third one we have concentration by Salpex process. What is this Salpex process? In all the process, it is same conversion of O into aluminum hydroxide, and finally aluminum hydroxide is being changed into aluminum oxide, pure aluminum oxide. So if silicon dioxide, if sand is present as impurity, if sand is present as an impurity, this process is employed. This process is employed, that is called what? Salpex process. So the O is mixed with coke. In this process, what happens? Aluminum oxide, that is bauxite, is mixed with coke along with nitrogen, and it forms aluminum nitride, 2 moles of aluminum nitride along with 3 moles of carbon monoxide. So this silicon dioxide combines with carbon and forms silicon plus carbon monoxide. Silicon plus carbon monoxide. So aluminum nitride on heating forms when dissolved in water. Aluminum nitride on dissolving in water, it forms aluminum hydroxide along with nitrogen gas. along with nitrogen gas. This reaction balancing can do. So we can have it 3 moles of H2O. So we can take, so this aluminum hydroxide, so 2 moles of aluminum hydroxide, so 2 moles of ALN and 3 moles of H2O. This aluminum hydroxide on heating at 1500 degrees C forms aluminum oxide, that is alumina, plus water. So this is nothing but surflex process. So we have three processes involved in the concentration of alumina. Suppose if alumina, that is bauxite ore, contains only ferric oxide, that is Fe2O3 is present, we'll concentrate the ore by using Bayer's process. In this process, aluminum oxide is the red oxide is treated with sodium hydroxide, and finally it forms aluminum hydroxide, and aluminum hydroxide on heating forms concentrated aluminum oxide. Second process we have, if the bauxite ore contains both ferric oxide and silicon dioxide as impurity, we will extract it by Hall's process that we have discussed already. And in this process, Hall's process, aluminum oxide is treated with sodium carbonate. That is, bauxite is treated with sodium carbonate. And the third step, if silicon dioxide is present as an impurity, it is been concentrated aluminum oxide, that is bauxite, is concentrated by surflex process. In this process, aluminum oxide is treated with carbon and nitrogen and forms aluminum nitrate. This aluminum nitrate on dissolving in water forms aluminum hydroxide, and aluminum hydroxide on heating forms aluminum oxide. So there are three methods for the concentration of alumina. There are three methods for the concentration of alumina, and after getting concentration of alumina, we'll do electrolytic refining of alumina. So that we are going to discuss now. So first, concentration and formation of aluminum oxide is done. Now second, in the metallurgy of aluminum, purified aluminum oxide. So whatever the aluminum oxide got from the above process, that is called purified aluminum oxide, is mixed with cryolite and fluorspar. This is very, very important. This is called cryolite and cryolite. So I'll write the spelling again. So Na3AlF6 is called what? It is called cryolite. And the CaF2 is called what? It's called fluorspar. So why we are adding this in the electrolytic refining of aluminum oxide? So this is mixed with aluminum oxide because it lowers the melting point and brings conductivity. Actually, to conduct electrolytic refining of aluminum oxide, to conduct electrolytic reduction of aluminum oxide cannot conduct electricity because the melting point of aluminum oxide is 2000 degrees C, and at this high temperature, it is difficult to do electrolytic reduction. It is difficult to do electrolytic reduction. It is difficult to do electrolytic reduction. So to reduce the melting point of aluminum oxide to 900 degrees C, so this cryolite and fluorspar is added, which lowers the melting point, then it becomes 900 degrees C and brings conductivity. The fusion matrix is electrolyzed. Steel vessel with the lining of carbon acts as cathode and graphite is used as anode. The process of electrolysis is widely known as Hall-Heroult process. So this process of aluminum oxide, this conversion of aluminum oxide to alumina is called Hall-Heroult process. So very, very important point. This they'll ask in the examinations also. In the metallurgy of aluminum, purified aluminum oxide is mixed with cryolite and fluorspar to reduce the melting point of alumina and brings about conductivity. So the fusion matrix is electrolyzed. Steel vessel with lining of carbon acts as cathode and graphite is used as anode. So the process of electrolysis is widely known as Hall-Heroult process. This is called as Hall-Heroult process. Very, very important. So please note it down. Next continuation. So this is called Hall-Heroult process. By this we can do electrolytic reduction of alumina. Electrolytic reduction of alumina. This is called as electrolytic, means by the means of electrolysis, that is cathode and anode, we will do electrolysis, electrolytic reduction of alumina, reduction of aluminum oxide, that is called as alumina. So this is called Hall-Heroult process. Hall-Heroult process. Hall-Heroult process. So what happens here? Pure alumina is a bad conductor of electricity. The fusion temperature of pure alumina is about 2000 degrees C, And at this temperature, when the electrolysis is carried out of fused mass, the formed metal vapor is as the boiling point of aluminum is 1800 degrees C. So the above difficulties are overcome by using a mixture containing alumina, cryolite, and fluorspar in the ratio of 20. So what is the ratio? That is 20 is to 24 is to 20. So that is aluminum oxide, cryolite, and fluorspar. Fluorspar ratio CF2. So the ratio in the 20 is to 24 is 20. So what happens at this mixture, this fusion temperature of this mixture is 900 degrees C. What is the fusion temperature of the mixture? 900 degrees C. So, and it is a good conductor velocity. So in this case, what happens? Aluminum oxide is being converted into alumina. That is aluminium, sorry. Aluminum oxide is converted into aluminium. So molten aluminium, sodium fluoride, so this cryolate and fluorspar is added. Carbon lining cathode, outlet for aluminum. So here we'll get aluminum in this process. We'll get what? Aluminum is formed at cathode. So where aluminum is formed at cathode. As we have already seen, aluminum is formed at cathode. So this is very, very important point. So what is the fusion mixture? The fusion mixture of aluminum oxide is very high, that is 2000 degrees C. And to decrease the melting point and increase the conductivity, we will add for this aluminum oxide, cryolate and fluorspar in the ratio of 20 is to 24 is 20. And this fusion mixture is ready to melt at 900 degrees C. Ready to melt at 900 degrees C so that the melting point is low and conductivity also increases. Due to this, what happens? We'll get aluminum at cathode. So this is called Hall halide process. Let us discuss now. So aluminum fluoride combines at cathode. What happens? Aluminum fluoride first changes to aluminum ion plus fluorine ion. At cathode, this aluminum ions gains electron and forms alumina. That is called reduction takes place. What is taking place at cathode? Reduction, because gaining of electrons is called reduction. And at anode, this fluorine ions changes to fluorine molecule. That is called oxidation. At anode, what is taking place? Oxidation. So this fluorine combines aluminum oxide again, aluminum fluoride. So again, this process is being repeated. So carbon plus melt forms carbon monoxide, carbon dioxide plus 2 electrons. So the overall reaction may be written as 2 moles of aluminum oxide combines with carbon, because carbon is taken as cathode, forms 4 moles of aluminum, 3 moles of carbon dioxide. This is the overall reaction. So this reaction is important. So finally we got aluminum. Finally we got what? Aluminum. So this is called extraction of aluminum. Extraction of aluminum. Very, very important. From this, they'll ask questions in the entrance exams. So it's clear now. Let us see next. Copper from low grade ores and scrap. Copper is extracted by hydrometallurgy from low grade ores. It is leached out using acid or bacteria. So it is leached out to use using acid or bacteria. The solution containing cuprous ions, that is copper ions, is treated with scrap ion or hydrogen in this case. So they are treated with ion or hydrogen, and iron being more electropositive metal can displace copper from its salt solution. Can displace copper from its salt solution. Even hydrogen also being more electropositive than copper ions, so can displace copper from its salt solution. So copper is displaced from its salt solution by means of iron and hydrogen. So that is nothing but copper is formed from low grade ores and scrap. So copper is extracted by hydrometallurgy from low grade ores. It is leached out using acid or bacteria. The solution containing copper ions is treated with scrap iron or hydrogen, where copper is getting reduced. Copper is getting reduced. So copper ions reduced to copper. Copper ions is reduced to copper. So this is nothing but extraction of copper from other sources. Now let us recap of this session. So first we have done copper, extraction of copper. So I'll give flow chart of extraction of copper, flow chart of aluminum, and flow chart of zinc. Easily you can understand. So flow chart of copper extraction. So flow chart of copper extraction. First what we have copper pyrites. copper pyrites. It is crushed and sieved. Then it's been done by concentration of copper pyrites, that is froth flotation. First step, what you will do? Froth flotation of copper pyrites, because copper pyrites form by CuFeS2. So in this, what happens? Concentration of copper pyrites takes place by the means of froth flotation. Second, what we have done after froth flotation, we have to do roasting. Conversion of copper pyrites, that is done by roasting in reverberatory furnace. Roasting in reverberatory furnace. Reverberatory furnace. And after doing roasting, what happens? What is formed? What is formed? We have matty and slag. We have what is formed? Matty is formed. Matty. Matty is formed. What is matty is called? Matty is nothing but what? It is nothing but mixture of copper sulfide plus iron sulfide. It is formed, and this is being converted into cuprous oxide by using oxygen gas by roasting. So this is converted into cuprous oxide. Third step, that is called, this is nothing but bismutherization. This is nothing but what? Third step, we have bismutherization. Bismutherization of copper sulfate, that is MATI. Bismutherization of MATI. So in bismutherization of MATI, what is formed followed by auto reduction is nothing but auto reduction, auto reduction, auto reduction. Copper is formed. What is formed? Blister copper is formed. Blister copper is formed. Blister copper is formed. What is blister copper? 98% pure copper is called blister copper. So this blister copper is being done by the means of finally electrolytic refining. Electrolytic refining. Electrolytic refining. So blister copper is treated with electrolytic refining. Then you'll get 99.6% copper. 99.6% to 99.9% copper. So this is the flow chart of copper extraction. Copper pyrites. First copper pyrites is taken. First process is fourth flotation. Second process is roasting. Third process is bismutherization of MATI. And fourth process is auto reduction. And fifth process is electrolytic refining. So these are the various steps involved in the extraction of copper. Now let us see extraction of zinc. Extraction of zinc. Final flow chart I'm giving for your understanding. It will be easy for you if you note down this. So extraction of zinc, very, very important. So first from zinc blend, that is zinc sulfide. So first zinc blend is taken, zinc blend, it is taken and undergoing froth flotation. Concentration can be done by froth flotation. So that is concentration can be done by using zinc sulfide concentration. Second, what we'll do first, after that we'll do roasting, roasting of zinc sulfide, roasting of zinc sulfide, which forms zinc oxide, which results in the formation of zinc oxide. Roasting of zinc sulfide, which results in the formation of zinc oxide. So this is nothing but roasting in reverberatory furnace. And third step, this is first step. Second step, third step, what we have? Third, we have reduction of zinc oxide. Reduction of zinc oxide by carbon. Reduction of zinc oxide by carbon. So it forms zinc spelter. Zinc spelter. What is it forms? It results in the formation of zinc spelter. So what are the impurities zinc spelter contains? Lead. Impurities are lead, iron, cadmium, etc. Lead, iron, and cadmium. These are the impurities formed. Now, fourth one we have done distillation. Distillation means nothing but purification of zinc. Distillation to get pure zinc. Distillation to get pure zinc. pure zinc, or even electrolytic refining also. Distillation or electrolytic refining. Electrolytic refining. So the impurities will be removed off from this. So either these two methods we can do. And in electrolytic refining, zinc deposits at cathode. Zinc deposits at cathode. So this is the extraction of zinc from zinc blend. 4 steps. First one, fourth flotation. Here concentration of zinc sulfide can be done. Second one, roasting of zinc sulfide to zinc oxide. Third one, reduction of zinc oxide by carbon, that is zinc spalter is formed, and the impurities are lead, iron, cadmium, etc. And fourth one, distillation of to get pure zinc, or electrolytic refining to get pure zinc. So these are the 4 steps involved in the extraction of zinc from zinc sulfide. So please note it down. Next we have, so I hope you have noted it. Next we have aluminum oxide. Extraction of aluminum from bauxite. Extraction of aluminum from bauxite, that is red bauxite or any bauxite. So in this extraction of aluminum from bauxite, first we have concentration of bauxite. Concentration of bauxite. So concentration of bauxite can be done in this first process. It can be done by, three ways. First way we have Bayer's process. Second way we have Hall's process. Third way we have Surpex process. So when we will use this Bayes process, if ferric oxide is present as impurity, if ferric oxide is present as impurity, we will use Bayes process. Then we will use Hall's process if ferric oxide and silicon dioxide are present as impurity. Silicon dioxide as impurities. If only silicon dioxide as impurity, we will use Surpex process. So this is first step. Step 2. What is step 2 in extraction of aluminum, that is bauxite? Step 2 is nothing but what? Calcination of aluminum hydroxide. Step 2 we have calcination of aluminum hydroxide. And step 3 we have electrolytic reduction of alumina. Electrolytic reduction of alumina. This is very, very important. Step 3 is most important. Step 1 and step 3 is most important. From this only you'll get questions. And fourth one we have refining of aluminium. Refining of aluminium by Hoops process. Hoops method. So these are the 4 steps involved in the extraction of aluminum from bauxite. So in this session, we have successfully extracted 3 metals from their ores. So all these 3 metals extractions are very important from for the entrance examination. So whatever the matter we have given, it is more sufficient. So please listen carefully. Now we'll do questions based on these. Questions based on the extractions. We'll do based on the extraction of metals. Questions based on the extraction of metals now. Let us continue with this. I will start questions based on the extraction of aluminum, copper, and zinc. Question number 1. The function of fluorspar in the electrolytic reduction of alumina dissolved in fused cryolite is option A as a catalyst, option B to lower the temperature of the melt and improve the conductivity, to lower the temperature of the melt and increase conductivity of the cell, option C to decrease the rate of oxidation, to decrease the rate of oxidation, and fourth option to increase the rate of oxidation, to increase the rate of oxidation. So why fluorspar is added? As we already know, fluorspar is added to lower the temperature of the melt and increase the conductivity of the cell. So this is an extraction of alumina so that the fusion temperature becomes 900 degrees C. So this we already discussed. So this answer is B, second option. So this type of questions you will get in the examination from the extractions. Definitely they are asking about methods. So please listen carefully. Next question. Question number 2. Question number 2. In Bessemer converter, in Bessemer converter, in Bessemer converter, copper sulfide is converted in the blister copper by copper sulfide is converted into blister copper by first option self reduction, second option reduction with coke, third option that is C, reduction with coal, reduction with coal gas, and fourth option reduction with hydrogen gas, reduction with hydrogen gas. So in a decimal converter, cuprous sulfide is converted into blister copper. Blister copper is what? 98% pure copper. By self-reduction, reduction with coke, reduction with coal gas, and reduction with hydrogen gas. So we already know blister copper, that is copper's cuprous sulfide combined with cuprous oxide and forms copper. 6 moles of copper along with sulfur, copper sulfur, cuprous sulfide again. So this already we have seen in the extraction. This flow chart. I'll write the complete equation if you want. You can see here. So this blister copper is being converted into normal copper by means of 6 moles of copper plus 1 mole of sulfur dioxide. 1 mole of sulfur dioxide. So this we have to take it as 2Cu2. So this is the answer is what? Self-reduction. That is called self-reduction. This is called self-reduction. 6 moles of copper is formed and 1 mole of sulfur dioxide is formed. So I hope it is clear. Next question. Question number 3. Spelter is impure form of spelter is spelter is impure form of option A, it is zinc. Option B, it is silver. Option C, it is copper. And option D, it is iron. So we already know zinc spelter contains contains lead, iron, cadmium, etc. as impurities. So the impure form of zinc is nothing but zinc spelter. Spelter is the impure form of zinc. I hope it is clear. Next question. Question number 4. In the extraction of copper, in the extraction of copper, the smelt formed in the blast furnace, smelt formed in the blast furnace contains formed in the blast furnace contains option A is nothing but cuprous sulfide plus little FeS. Option B, cuprous sulfide plus FeO. Option C, cuprous sulfide plus little cuprous sulfide plus cuprous oxide. And option D, cuprous oxide plus FeO, little FeO. So this is already we know. So in the extraction of copper, the smelt formed in the blast furnace contains cuprous sulfide and little FeS. This is also called as matte. What is formed? Matte is formed. Matte is formed. It is nothing but in the basement, in the blast furnace, matte is formed. Nothing but a mixture of cuprous sulfide plus iron sulfide. So answer is first option. Next, I hope it is clear. So please copy down in your classwork. Next, continuation. Question number 5. So like these questions we are going to get in the entrance examination. So based on the experiments also they'll give. So everything you should be thorough with. It's very, very simple. In the electrolysis of alumina, in the electrolysis of alumina using cryolite, the reaction that takes place at cathode is the reaction that takes place at cathode is option A, 2 moles of 12 moles of fluorine changes to 6 moles of fluorine plus 2 electrons. Option B, 4 moles of water combines with 4 electrons and forms 2 moles of hydrogen gas plus 4 moles of OH minus. Option C, 6 moles of fluorine combines 2 moles of aluminum oxide uses to 4 moles of aluminum fluoride plus 3 moles of oxygen gas. And option D, 4 moles of aluminum plus 3 ions plus 12 electrons gives rise to 4 moles of aluminium. So already we know at cathode always reduction takes place. So reduction is only 2 here. Anyway, hydrogen cannot be formed from this equation. So answer is D option, because aluminium is obtained at cathode and always at cathode reduction takes place. So like these questions you may expect in the entrance examination. Very, very important. So you can practice more questions from this lecture. This lecture is very, very important. In this lecture, what we have done? We have done extraction of copper, extraction of zinc, and extraction of aluminum. All the three are very, very important for the entrance examination. So with this, you have completely done. That is extractions of aluminum, copper, and silver we have done. So with this, I'm ending this session. Please do whatever we are discussing in the exam in the lecture. Very, very important. So practice more questions in the on the extractions of zinc, aluminum, and copper. Easily you can do it. Thank you all.